so here we are looking at a closed cylinder. Closed just means that the top, of course, is going to be covered, and they tell us that the volume is 16 pi, and we're trying to figure out the least amount of surface area. And the reason why we know least amount of surface area would be the same as if they ask what is the least amount of material. So least amount means we're trying to minimize surface area, subject to the constraint that the volume is equal to 16 pi. So minimizing surface area, subject to volume is equal to 16 pi. Now, what's really nice about a closed cylinder is you can kind of reason out what the surface area would be and what the volume would be. So let's just take a minute to try to reason this through. All right, so if we have a closed cylinder and we think about covering this closed cylinder, we would have to cover the bottom of the cylinder. Now, if you look at the bottom of the cylinder, that is just a circle. And we know what the area of a circle is. It's pi r squared. So the bottom, when we cover that, will be pi r squared. And when we cover the top, that will also be pi r squared. So our surface area formula for a closed cylinder will have a pi r squared for the top and another pi r squared for the bottom. Now, if you think about going around the cylinder and covering all of the outer edge of the cylinder, if I just go around one time, I will trace out a circle. So just one time around the cylinder, I will have 2 pi r because I'm tracing the circumference of a circle. Now, I don't just have one little circle. I would have to go around another time, another time, another time, another time, another time, another time, until I have times h. Because I have to, going from the start to the top, I would have h times that I would need to trace that circle that has a circumference of 2 pi r. So the edge, so the bottom and the top, that's our pi r squared and pi r squared, and then the remaining part of the cylinder to cover that, I would have plus 2 pi r h, and that would be my surface area formula. Now, of course, when you look at your surface area formula, you have pi r squared, so you can combine those to get 2 pi r squared plus 2 pi r h. All right, so that's our surface area formula. Now, we have to go over here and think about what our volume formula would be. So remember, volume is going to be the contents of the cylinder. So if you think about the contents filling up the circle, or filling up the cylinder, if I fill up just one little cross-section of the cylinder, I would have a circle, and the area of that circle would be pi r squared. But again, I don't just have one cross-section of a circle. I have another cross-section of a circle that I have to fill up, another cross-section that I have to fill up, another cross-section I have to fill up. And so I am going to have h of these circle cross-sections to fill up the cylinder. So my volume will be subject to, the volume is equal to pi r squared h, and we know that our volume is supposed to equal 16 pi. Okay, so let's write out what exactly we're looking at here. We're trying to minimize this surface area function, 2 pi r squared plus 2 pi r h, subject to the volume pi r squared h is equal to 16 pi. Now, when you look at your little surface area formula, you got a problem here because you have two unknowns. You have r and h. So what we're going to do is we're going to go over here to our constraint and solve for one of the unknowns. Now, if I solve for r, I'm going to have to take a square root. So because of that, I'm going to solve for h, divide by pi r squared, divide by pi r squared, so I don't have to take any square root. And I get h is equal to, here the pi's cancel, so I have 16 over r squared. So this is subject to surface area, subject to that the height is equal to 16 over pi, or 16 over r squared. So once I have the 16 over r squared, we've talked about this before, we're going to substitute that 16 over r squared in for h. So this will become 2 pi r squared plus 2 pi r, and then in for h, we're going to plug in 16 over r squared. Okay, so again, at this point, we're saying to ourselves, this is looking good because we just have one unknown. Before we go and take our derivative, though, let's simplify. So our surface area function, you have a 16 times 2, so that gives us 32 pi, and then this r over r squared, that would reduce to just r in the denominator. But we know what's coming up. We have to take our derivative. So I'm going to move this r up into the numerator. And when I do that, I will get r to the -1. All right, so now our objective function is in one variable. And as soon as your objective function is in one variable, then you are ready to take its derivative and set it equal to 0 or does not exist. All right, so I'm going to take the derivative, and I get 4 pi r minus 32 pi r to the -2. Now, as we have discussed before, we always want to get a common denominator and get rid of our negative exponents. So I'm going to move the negative exponent down and then get the common denominator by multiplying the first term by r squared over r squared. So that gives us 4 pi r cubed minus 32 pi over r squared. And then we will set our numerator equal to 0 and denominator equal to 0. So we have 4 pi r cubed minus 32 pi is equal to 0. Denominator equal to 0 tells us where the derivative does not exist. Solving that, we get r is equal to 0. Over here, I'm going to add the 32 pi, divide by 4 pi, divide by 4 pi. We get r cubed is equal to 8. Take the cube root of both sides, and we get r is equal to 2. Now, you can sit there and be like, I have two critical numbers, r is equal to 2, r is equal to 0. But you guys, if you think about this, r is equal to 0. If your radius is equal to 0, you're not going to have a cylinder. So radius is equal to 0 means there's no cylinder around. And so this r is equal to 0 is a completely bogus answer, and that's telling us that r is equal to 2 is going to be the place or the minimization of our surface area. So we are going to verify this, and unfortunately my battery is at 5% on my phone, so I am just going to say we verify using either the first derivative or the second derivative test, and then to finish it up we do have to find the h value as well. So that's where we go back to our constraint, and it's nice if you can go back to the solved constraint of h is equal to 16 over r squared and just plug in the 2 squared, so you have 16 over 4, and so that gives us 4. So you're finding that our answer is that the radius is equal to 2 and the height needs to be equal to 4.